Good afternoon, everyone. In this video, I want to show you how to create descriptive statistics table and a regression table using R. I'll use a data set that I put together yesterday that uses several different sources. The first source is the most recent election results, and that came from the New York Times. It took a little bit to grab that data, but here New York Times gives me votes by each county in every state, and I took 6 swing states: Florida, Michigan, Iowa, Ohio, Pennsylvania, Wisconsin, and collected this data on vote by each county for Trump or Clinton. The second data source was the election results from 2012, 4 years ago, and that came from the Guardian magazine. They have a spreadsheet where you have election results for each county. Third data source was Bureau of Labor Statistics. That gives me the unemployment rate in 2015 and also in 2011, 4 years ago, for each county in the United States. Finally, the final source came from American Fact Finder, where you can get basic demographics. I believe I used this selected social characteristics, table DPO2. You can load it. If you add and remove geographies, you can say, oh, I just want it by county level, all counties within the United States. It gives you that table. You can download it and then put all those tables together. It takes some cleaning up. It's actually quite a bit of work, but in the end I have this cleaned up election data where I have counties. County is the unit of observation for 6 swing states. Vote for Trump, Clinton, the state, Obama, Romney in 2012, unemployment in 2011, unemployment in 2015, percentage of population with bachelor degrees, percentage of population with high school degrees, and percentage of population that's foreign born. Look at that. Miami-Dade has more than 50% population foreign born. If we go down here to Wisconsin, Jackson County, less than about 1%. So what I do is I take this cleaned up data and I load it into R, just like we've been doing. I put everything in my folder that in this case I call election results. So let me execute that. I read the R data, and did it load it? Did it load? Yeah, okay, it loaded beautifully. That's exactly what the spreadsheet should look like. Now, if I work with this data, I actually want to take some create some new variables. So for instance, I want to calculate the margin of victory for Trump. So I take the Clinton vote and I subtract that from the Trump vote and do the same thing in 2012. I also want to calculate the change in unemployment, and we do this the same way we did quadratic equations or logarithmic equations. We create a new variable. So we start with the name of the data frame, $, name of that new variable, and then a function of some existing variables. I also create a percent margin. So rather than the absolute change in votes, percentage difference between the votes. And I actually need to install a package, Stargazer. If you haven't installed that yet, you can click here on packages. Later, click install. Okay, I want to wait. Here you could type in Stargazer. I already have it installed, but that's how you install new packages. You may also want to install ggplot2 or dplyr, although I don't think I use dplyr in this program. Of course, once you install a package, then you need to tell the R session to use that package by executing this command, library ggplot, library Stargazer. I already loaded in the data. Let's create these new variables. and you would see that this spreadsheet expanded. Now I have the percent margin and the unemployment change and the margins of victory. Clearly we can see that Trump lost in Miami-Dade big time in both 2016 and 2012. So we are here. Let's create a table of descriptive statistics. We just type in Stargazer. We feed it the data frame that we want descriptive statistics of, and we want, in this case, I want text. I want just one digit decimal point, one decimal point. I don't want a lot of decimal points, and it creates a pretty nice table. So it gives us the number of observations, mean, standard deviation, minimum, maximum. You can actually ask it to give you also a median. Let's take a quick look at whether this all makes sense. Here are the average votes for Trump, Clinton, Obama, Romney. Unemployment rate in 2011. The average unemployment rate was 8.8. In 2015, it was only 5.2. Clearly, unemployment rate has declined, and you know that if you follow economic statistics or the economy as a whole. There's on average 20% of population have a bachelor's or higher. 88 has a high school degree, so that all makes sense. There are no big outliers here. Foreign born on average 3.6, but the minimum is 0.1, maximum is over 50%. That actually is the Miami-Dade County. Here's the margin. This is the margin of victory for the Republican in 2016. That's positive, 1,700 votes. In 2012, obviously the Republican lost, so their margin of victory is negative, 2,500 votes. Unemployment rate change. On average, unemployment rate declined 3.6 percentage points. The percent margin in 2016, on average, the Republican got twice as many votes as a Democrat. And that's, remember, this is average across counties. Democrats win large counties and do poorly in small counties. So this is unweighted. So if we average across all the counties, treating each county equally, the average margin of victory for Trump was 100%. The average margin of victory for Romney was 35%. It still means that he lost because he had a margin. He won lots of counties, but he didn't win the big counties. So this is a nice descriptive statistics table, and what we want to do when we play with data, we want to take a close look at it and make sure that the numbers that we see make sense. The other thing that you might want to do, and I didn't talk about this in class, so I'm not requiring you to do this, but visualizing the data. You certainly didn't have time to do this, but it is relatively easy to create pretty graphs, and certainly you should know how to create graphs in Excel. So some of these graphs you could do in Excel and put them in your paper. If you'd like to do them in R, it is relatively easy. It's this plotting package ggplot. It's a function ggplot. You tell it that you want to use a data frame R, and this aesthetics sort of tells it what you want on the x-axis, what you want on the y-axis, and what you want to plot. You want to plot points. And here I want to plot points, and I also want to plot a line. And a line where I plot margin in 2012 against margin in 2012. Plot something on the same thing, something on itself would give me a 45-degree line. So let's plot that. And here's what we get. So let's take a look at this, because sure, we care about the econometrics, but I also care about what's happening and what happened in this election. And so this is the margin of victory for the Republican in 2012, margin of victory for the Republican in 2016. So whenever the margin of victory is negative, that means that the Republican lost. So we could see that the Republicans lose by big margins. They lose the big counties, but they win lots of small counties by smaller margins. But when you add up lots of smaller counties and smaller margins, that adds up, and it certainly added up in 2016. Now we can actually also see that in 2016 the margin of victory is higher than it was in 2012. All these points, most of these points are above the 45-degree line. Okay, so if Romney won this county by a positive margin, Trump won it by a bigger margin. In contrast, look at this big county that Obama won by a big margin, and Trump lost by about the same margin. Okay, so there was no bigger. This is about the same margin in 2012 as in 2016. In this county, the margin of loss for Trump was much smaller. In 2016, it was closer to 0 than it was for Romney in 2016. So essentially, wherever the points are above the 45-degree line, Trump did better than Romney did in 2012. So I could talk about this more, but I want to keep this video to less than 5 minutes. I don't think that's going to happen, but let's plot one more. Let's plot a couple more. Let's plot it by percentage. So this is, I'm plotting the percent margin in 2012, percent margin in 2016. Again, all of these points are above the 45-degree line, clearly showing us that Trump did a lot better in all these counties than Romney did in 2012. Now, we're certainly interested in what drives what happened here. So let's plot the margin of victory for Trump against education. So what do we see here? We have education, percent of population with bachelor's degrees, and percent win for Trump. Clearly a negative relationship. More educated counties, Trump actually lost. In less educated counties, Trump won. Could do the same thing for high school. I'm not going to do that. I'm going to do, let's say, unemployment. Unemployment in 2015. Actually, there doesn't seem to be much of a relationship between the unemployment rate in 2015 and how much Trump won, or how he did. He didn't win everywhere, obviously. There's some percent margin that's less than 0. Let's do one last one. This one I plot percentage of foreign-born population on the horizontal axis, and again Trump margin of victory. It looks like a slightly downward sloping relationship. Certainly in foreign-born counties, this is the Miami-Dade county, Trump did not do as well as in counties where there's very little foreign-born population. Okay, so you can, if you're writing your paper, you might want to include some graphs. If not, it's okay, but it gives you something to talk about. It certainly helps your reader become comfortable with the data. It also helps you often identify errors in putting the data together. If something looks off, you can usually identify it by plotting a graph. Now let's start running some regressions. So I have model 1. Okay, so in model 1, I'm just going to plot the percent margin in 2016. That's going to be my dependent variable. That's what I want to explain. I want to explain why did Trump do better in some counties than in others. And of course, a lot of that is going to be driven how Republican or Democratic that county is. And I'm going to measure that using the percent of margin that Romney won or lost those counties in 2012. So let's run that. We got summary model 1. What do we see? Obviously, big, significant statistic that how Romney did in 2012 affects how Trump did in 2016. The slope is actually 1.4. It's actually greater than 1. So clearly Trump actually did better in the more Republican counties. This explains about 80% of the variation. About 80% of the variation in how Trump did is explained with how Romney did in 2012. Now, in the second model, I want to test the hypothesis that it was the economy that made Trump more successful. That in counties where people experienced an increase in unemployment rate, they were disillusioned with the Democratic administration and ran to Trump. Let's see if that works. So I add the change in unemployment. Right, so this is a positive if a county experienced an increase in unemployment. What do we see? No relationship whatsoever. Right, so clearly this was not that people felt that people were worse off than they were 4 years ago. That did not drive. That does not explain the variation in Trump's vote. Perhaps it's not the change in unemployment rate. Maybe it's the level of unemployment rate. So what I'm going to do is, in this model 3, is regress Trump's margin of victory as a dependent variable, controlling for how Republican or Democratic the county is, using the results from 2012, and I add the level of unemployment in 2015. Now, perhaps what's happening here is clearly positive and significant. So in counties where there's a lot of unemployment, people more likely voted for Trump. So his message clearly fell on more fertile ground in counties where there's economic anxiety. However, economic anxiety and certainly unemployment across counties is correlated with levels of education. In poor rural counties, the levels of education are lower. So let's see if this result holds when we control for education. What do we get? Oh, actually it flips the sign. It flips the sign. Look at that. So what do we see? The more education county has, the lower the vote for Trump. Not surprising. But controlling for education, actually the higher the unemployment rate, the lower the vote for Trump. So that goes completely against the original hypothesis that it was the economy that drove Trump vote. Certainly the hypothesis that would point to education, his message resonated more with the less educated counties, is supported by this data. Model 5, let's add foreign-born population. It changes things a little bit. No, actually, still the coefficients are still significant. They still have the same signs. Foreign-born, not surprisingly, has a negative effect on Trump's margin of victory. Finally, Model 6. This is something that you have not seen before. I'm going to control for state dummies. Okay, and in R, it's actually very easy to do because I can just type in state. I don't need to create the dummies in Excel, although you could certainly do that. But I can just type in the state, and R recognizes that the state is a character variable, and it creates dummies accordingly. I have 6 swing states, and it creates 5 dummies. So we got a dummy for Iowa, Michigan, Ohio, Pennsylvania, Wisconsin. Florida is the left out category. So that actually rendered foreign-born insignificant. Education still matters. Now unemployment matters positively. So again here the evidence that economic anxiety drove some of the Trump vote looks like it's mixed. In some specifications significant, in others it is not. Clearly, the most robust result is the effect of education on Trump vote. So this is what we're doing. This is what we do when we run regressions. When we have data, we test different ideas. We see how what is the story that the data is telling us. And here, the story that the data is telling me is that the evidence on economic anxiety driving Trump vote is not particularly strong. Education is certainly much stronger. Now, how do we put this in a paper? Here, Stargazer is just a beautiful command, beautiful function that can do this for you. I'm not going to put all 6 models in my paper. I'm actually going to just put model 2, 3, 4, and 6. And I think I can tell my story about education and economic anxiety or unemployment with just those 4 specifications. So I tell it that I just want 2 decimal points on coefficients and other statistics, and boom, here it is. Okay, look at this. This is just a beautiful table. I don't have to type things in. It is even putting the asterisks exactly where I want them. It gives me the number of observations, the R squared. Could not ask for more. I guess one thing you could ask, if you're writing your paper in Word, you would like this to be nicely exported into Word. Now this is plain text, so it doesn't export that nicely. One thing you could do is you can run the Stargazer on and ask for HTML type, and then output that table into a file called table HTML. So if I run that, it puts that table HTML in my working directory. My working directory is this research election, and if I click on that, it gives me the HTML version of the table, which I can open in Word. I can open a new file. Let's see, how do we do this? Yeah, open here, table, open, and there. That's my table in Word. I can certainly take it, copy it, and wherever I have my document with my text, I can paste it in there. So this is certainly more than 5 minutes, but I'm gonna stop here, and I'll see you tomorrow.